Hey everyone, welcome to PLA Academy. Hope you found this video useful. If you did, it'd be awesome if you could subscribe, like the video, share it with your friends, and maybe drop a comment. Your support really helps me make more videos. In this video, I covered everything on the syllabus, like you can see in the figure. Work done is the product of force and displacement moved in the direction of the force. It is a scalar quantity, and its unit is joule. The formula of the work done is W equals Fd. Where W is work done in joule, F is the force in newtons, and D is the displacement moved in the direction of the force in meters. When the force and the displacement are in the same directions. In this case, the work done is positive. If a 5 newtons force acts on a box, causing it to move 10 meters in the same direction, are shown. The work done can be calculated using W equals Fd. Substituting F equals 5 newtons and D equals 10 meters. We get the work done equals 50 joule. When the force and the displacement are in the opposite directions. In this case, the work done is negative. If a 5 newtons force acts on a box to the left while the box moves 10 meters to the right, are shown. The work done can be calculated using W equals Fd. Substituting F equals 5 newtons and D equals negative 10 meters. We get the work done equals negative 50 joule. The negative sign indicates that the force opposes the displacement. When the force F acts on a box at an angle theta to the horizontal, causing the box to move d meters to the right, are shown. The force F can be resolved into horizontal and vertical component. The horizontal component is F cos theta, and the vertical component is F sin theta. F cos theta is in the same direction to the displacement d. This component does work W on the box as F cos theta times d. F sin theta is perpendicular to the displacement d. This component does not work on the box. When a person walks 10 meters while holding a box weighing 10 newtons, the person exerts a force of 10 newtons to hold the box. However, the box moves forward in a direction perpendicular to this force, are shown. Therefore, the work done by the person holding the box is 0. When the gas in the cylinder does work on a piston of cross-sectional area A, the pressure P on the piston has a constant value. The force F due to the gas pressure acting on the piston causes the piston to move outward with distance delta x. The work done W by the gas is given by W equals F delta x. The force F exerted by the gas is equal to the pressure P multiplied by the area A as F equals PA. Since A, delta X, is the change in the volume of the cylinder delta V. Therefore, the work done by the gas can be expressed as W equals P delta V. Exam style question 1. A team of 9 dogs can pull a sledge with a combined force of 800 newtons at a speed of 1.5 meters per second for 360 minutes. What is the average work done by each dog during this time? The work done can be calculated using W equals Fd. The force F of 9 dogs equals 800 newtons. The distance d can be calculated using d equals speed v multiplied by the time t. Substituting v equals 1.5 meters per second and t equals 360 times 60 seconds. So, the distance d equals 32,400 meters. Substituting F equals 800 newtons and d equals 32,400 meters. We get the work done by 9 dogs equals 25,920,000 joule. So, the work done by 1 dog equals 25,920,000 divided by 9 is equal to 2.9 times 10 power 6 joule for 2 significant figures. Exam-style question 2. A piston in a gas supply pump has an area of 600 square centimeters, and it moves a distance of 40 centimeters during one stroke. The pump moves the gas against a fixed pressure of 5,000 pascals. How much work is done by the piston during one stroke? The work done by the gas can be calculated using W equals Fd. The force F by the gas can be calculated using F equals Pa. The pressure P by the gas equals 5,000 pascals. The area, A, equals 600 square centimeters. We convert the area, A, into square meters, like this, which is 0.06 square meters. The distance D equals 0.4 meters. Substituting P equals 5,000, A equals 0.06, and D equals 0.4. We get the work done by the gas W equals 120 joule. Energy is the ability to do work. It is a scalar quantity, and its unit is joule. There are many forms of the energy as follows. Kinetic energy is the energy due to the movement of a mass. Gravitational potential energy stored in a mass due to change in its position within a uniform gravitational field strength. Elastic potential energy, or strain energy, stored in an object due to change in its shape. Chemical potential energy. Electrical potential energy is the work done by the electric force due to the electric field. Thermal or heat energy. Radiation energy, for example light, infrared or gamma. Sound energy. Nuclear energy. Principle of conservation of energy. The energy cannot be created and destroyed, but can only be transferred from one form to another. Principle of work energy. Work done and the energy principle state that mechanical or electrical work done is equal to the energy transferred. Derive the formula of the kinetic energy as Ek equals half of m square v. A force F pushes a box along a smooth surface, causing a displacement of s. The box's velocity increases from an initial value of u to a final value of v. Since the surface is smooth, there is no thermal energy loss. Therefore, all the work done W by the force F is transferred to an increase in kinetic energy delta Ek. The work done by the force F, W equals Fs. So, delta Ek equals Fs. The force F equals ma. From the equation V squared equals U squared plus 2as. So as equals half of V squared minus U squared. Substituting as into this equation like this. So, delta Ek equals m half of V squared minus U squared. Assuming that the initial velocity U equals 0. Therefore, delta Ek equals half of m square V. Derive the formula of the gravitational potential energy as Ep equals mg delta H. A box with a mass m kilogram being lifted from the ground to a higher level with a height delta H. Since we use the force F that equals box's weight to hold the box, so F equals mg. Therefore, all the work done W by the force F equals mg is transferred to an increase in gravitational potential energy delta Ep. The work done by the force F, W equals Fs. So, delta Ep equals Fs. The force F equals mg. The distance s equals delta H. Therefore, delta Ep equals mg delta H. Exam-style question 3. When a horizontal force F is applied to a frictionless trolley over a distance s, the kinetic energy of the trolley changes from 4 joule to 8 joule. If a force of 2F is applied to the trolley over a distance of 2s, what will the original kinetic energy of 4 joule become? The frictionless surface means that no heat energy loss, or no work done against friction. So, the work done by the force F equals the kinetic energy gain. The work done by the force F equals F times S, and EK gain equals 8 joule minus 4 joule. So, Fs equals 4 joule. If a force of 2F is applied to the trolley over a distance of 2s, the original kinetic energy of 4 joule become the final kinetic energy EK. So, 4Fs equals EK minus 4 joule. And EK equals 4Fs plus 4. Substituting Fs equals 4. We get the final EK equals 20 joule. Exam style question 4. A constant force of 9.0 kilonewtons, parallel to an inclined plane, moves a body of weight 20 kilonewtons through a distance of 40 meters along the plane at constant speed. The body gains 12 meters in height, as shown. How much of the work done is dissipated as heat? The box moves at constant speed to indicate that its kinetic energy remains the same. So, the work done by 9 kilonewtons force equals the gravitational potential energy gain plus work done against friction, or dissipated heat energy. Therefore, F times S equals mg delta H plus dissipated heat. Substituting F equals 9,000 newtons, mg equals 20,000 newtons, delta H equals 12 meters. We solve the dissipated heat equals 120,000 joule. Exam style question 5. A uniform solid cuboid of concrete of dimensions 0.5 meters times 1.2 meters times 0.4 meters, and weight 4,000 newtons rests on a flat surface, with the 1.2 meters edge vertical, as shown in diagram 1. What is the minimum energy required to roll the cuboid through 90 degrees to the position shown in diagram 2 with the 0.5 meters edge vertical? The solid cuboid will topple over if a vertical line drawn downward from its center of gravity falls outside its base area are shown. So, the minimum energy required to rise the cuboid's center of gravity is mg delta H. Therefore, delta H equals the difference between the center of gravity A and B. This distance is half of 12 meters equals 0.6 meters. The distance x is half of the diagonal of cuboid. This distance is half of 0.5 meters equals 0.25 meters. The distance x can be calculated using the Pythagorean theorem like this. We solve the distance x equals 0.65 meters. So, delta H equals 0.65 minus 0.6 is equal to 0.05 meters. Substituting mg equals 4,000 newtons and delta H equals 0.05 meters. We get the minimum energy required equals 200 joule. Exam style question 6. A box of weight 200 newtons is pushed so that it moves at a steady speed along a ramp, through a height of 1.5 meters. The ramp makes an angle of 30 degrees with the ground. The frictional force on the box is 150 newtons while the box is moving. What is the work done by the person? The box moves at constant speed to indicate that its kinetic energy remains the same. So, the work done by the person equals the gravitational potential energy gain plus work done against friction, or dissipated heat energy. Therefore, the work done by the person equals mg delta H plus friction times distance d. Therefore, distance d is the distance along the ramp, like this. So, sine 30 equals delta H divided by d. We solve the distance d equals 1.5 divided by sine 30 equals 3 meters. Substituting mg equals 200 newtons, delta H equals 1.5 meters, friction equals 150 newtons, and d equals 3 meters. We get the work done by the person equals 750 joule. Exam style question 7. A trolley runs from P to Q along a track. At Q its potential energy is 50 kJ less than at P. At P, the kinetic energy of the trolley is 5 kJ. Between P and Q, the work the trolley does against friction is 10 kJ. What is the kinetic energy of the trolley at Q? The kinetic energy of the trolley at P equals 5 kJ. When the trolley runs from P to Q, the work done against friction, or heat energy loss, is 10 kJ, and the kinetic energy at Q is Ek. Therefore, the gravitational potential energy loss from P to Q equals 50 kJ. So, the gravitational potential energy loss equals the kinetic energy gain plus work done against friction. Substituting EP loss equals 50 kJ, Ek gain equals Ek minus 5 kJ, and work done against friction equals 10 kJ. We solve the Ek at Q equals 45 kJ. Power is the work done per unit time, or energy transferred per unit time. It is a scalar quantity, and its unit is watts or joule per second. The formula of the power P equals W divided by T, or E divided by T. Where P is the power in watts, W is work done in joule, T is time in seconds, and E is the energy in joule. If we substitute work done W equals force F times displacement D into P equals W over T, where D over T is speed V. So, the power P equals F times V, like this. Exam style question 8. An area of land is an average of 2 meters below sea level. To prevent flooding, pumps are used to lift rainwater up to sea level. What is the minimum pump output power required to deal with 1.3 times 10 power 2 kilograms of rain per day? The power can be calculated using P equals E divided by T, where the energy E equals gravitational potential energy mg delta H. The mass m equals 1.3 times 10 power 9 kilograms. The gravitational field strength G equals 9.81 meters per square second. The delta H equals 2 meters. The time T is 1 day, converting into second, which is 86,400 seconds. Substituting m, G, delta H and T in the equation, like this. We get the power P equals 300 kilowatts for two significant figures. Exam style question 9. The diagram shows a lift system in which the elevator, mass m1, is partly counterbalanced by a heavy weight, mass m2. At what rate does the motor provide energy to the system when the elevator is rising at a steady speed v? G equals acceleration of free fall. The system moves at steady speed to indicate that its kinetic energy remains the same. So, the power input by the motor equals the rate of gravitational potential of the system loss. When the elevator moves upward at steady speed v with distance delta h. So, its kinetic energy is constant and its gravitational potential energy gain as m1 g delta h. The mass m2 moves downward at steady speed v with distance delta h. So, its kinetic energy is constant and its gravitational potential energy loss as m2 g delta h. So, the power input by the motor equals m2 g delta h minus m1 g delta h over t. We factor out g delta h like this. The delta h over t is the steady speed v. So, the power input by the motor equals m2 minus m1 gv. Exam style question 10. A mass of 2 kilograms rests on a frictionless surface. It is attached to a 1 kilogram mass by a light, thin string which passes over a frictionless pulley. The 1 kilogram's mass is released and it accelerates downwards. What is the speed of the 2 kg mass as the 1 kg mass hits the floor, having fallen a distance of 0.5 meters? This question can solve using the Suvat equations, or the principle of conservation of energy. But I will solve using the principle of conservation of energy. When a 1 kg mass moves downward 0.5 meters, causing its speed to increase from 0 to v. This causes a 2 kg mass also moves 0.5 meters to the right, and its speed also increases from 0 to v. The frictionless surface causes no heat loss or no work done against friction. Therefore, the gravitational potential energy of system loss equals the kinetic energy of system gain. The EP loss equals mg delta H, and EK gain equals half m square V minus half m square U. A 1 kg mass moves downward causes EP loss equals 1 times 9.8 1 times 0.5. Both masses increase its speed from 0 to v to cause EK gain equals half of 1 plus 2 times square v minus 0. We solve the speed v equals 1.8 meters per second for two significant figures. Exam style question 11. An escalator is 60 meters long and lifts passengers through a vertical height of 30 meters, as shown. To drive the escalator against the forces of friction when there are no passengers requires a power of 2 kilowatts. The escalator is used by passengers of average mass, 60 kilograms, and the power to overcome friction remains constant. How much power is required to drive the escalator when it is carrying 20 passengers and is traveling at 0.75 meters per second? The escalator moves at constant speed 0.75 meters per second to indicate that its kinetic energy remains the same. Therefore, the power drive the escalator and passengers equals power when no passenger plus power drives 20 passengers. The power drives 20 passengers equals work done Fd divided by time t. F equals the total weight of 20 passengers equals 60 times 9.81 times 20 is equal to 11,720 newtons. D equals the vertical height of the escalator equals 30 meters. T equals the time of the escalator moving at 0.75 meters per second for 60 meters. So, T equals 60 divided by 0.75 is equal to 80 seconds. Substituting F equals 11,720, D equals 30, and T equals 80. We get the power to drive 20 passengers equals 4,414.5 watts. Therefore, the power drives the escalator and passengers equals 2,000 plus 4,414.5. We get the results is 6.4 kilowatts. Exam style question 12. A conveyor belt is driven at velocity v by a motor. Sand drops vertically onto the belt at a rate of m kilograms per second. What is the additional power needed to keep the conveyor belt moving at a steady speed v when the sand starts to fall on it? When sand drops vertically onto the belt, as shown, the belt exerts a force F on the sand, and the sand exerts an equal and opposite force F on the belt. The additional power needed to keep the conveyor belt moving at a steady speed v to calculate using P equals F times v. The force F can be calculated using mv minus mu over t. The initial velocity u of the sand equals 0, the final velocity v of the sand equals v, the sand's mass m equals m, and the time t equals 1 second. Substituting all quantities in the equation like this, we get the force F equals mv. Substituting F equals mv and v equals v, we get the additional power equals m square v. Efficiency is the ratio of the useful energy, or work or power, output from the system to the total energy, or work or power, input. Exam style question 13. A constant force F, acting on a car of mass m, moves the car up the slope through a distance s at constant velocity v. The angle of the slope to the horizontal is alpha. Which expression gives the efficiency of the process? The efficiency of this question can be calculated using the efficiency equals useful energy, or work output divided by total energy, or work input. The useful energy output is the gravitational potential energy gain of the car equals mg delta h. The delta h is the vertical height. And sine alpha equals delta h divided by s. So, delta h equals s times sine alpha. Therefore, EP gain equals mgs sine alpha. Total energy input equals the work done by the force F. So, the work done by the force F equals F times S. Therefore, the efficiency equals mgs sine alpha divided by Fs. We cancel out S, like this. Since, the result is mg sine alpha over F. Exam style question 14. A bow of mass 400 grams shoots an arrow of mass 120 grams vertically upwards. The potential energy stored in the bow just before release is 80 joule. The system has an efficiency of 28%. What is the height reached by the arrow when air resistance is neglected? The efficiency can be calculated using the efficiency equals useful energy output divided by total energy input. The efficiency equals 28%. The useful energy output equals GPE gain equals mg delta H. The total energy input equals the potential energy storing in the bow. GPE gain equals 0.12 kilograms times 9.81 times delta H. The potential energy storing in the bow equals 80 joule. We solve the delta H equals 19 meters for two significant figures. Exam style question 15. Water from a reservoir is fed to the turbine of a hydroelectric system at a rate of 500 kilograms per second. The reservoir is 300 meters above the level of the turbine. The electrical output from the generator driven by the turbine is 200 amperes at a potential difference of 6,000 volts. What is the efficiency of the system? The efficiency of this question can be calculated using the efficiency equals useful power output divided by total power input. The useful power output equals the electrical power equals VI. The total power input equals the gravitational potential energy per second of the water. The electrical power equals 6,000 volts times 200 amperes. The gravitational potential energy per second of the water equals 500 kilograms per second times 9.81 times 300 meters. Therefore, the efficiency equals 82% for two significant figures. I hope you found this video helpful. If you did, I would be grateful if you would subscribe, share, like and leave a positive comment. Your support will encourage me to create more content. Thank you.